The next topic here is essential elements. Excuse me. So, elements, those things from the periodic table of the elements. They are the atoms that make up everything. And some of these are essential for life. We are carbon-based life forms here on Earth. So plants, animals, bacteria, fungi, doesn't matter. We're all based on carbon as the structural centerpiece of the atoms that make up most of our bodies, with some other things like hydrogen and oxygen and other atoms that make up the components of plants and animals and all other life. So how do they get them? How do these organisms get these elements that make up the bodies and grow? And we get it through eating and breathing. We get certain of the elements like oxygen from breathing, but much of what we take in through eating. And plants don't have mouths, so they can't eat, so they have to have the ability to absorb most of these elements through their roots in a dissolved soluble form. So these elements are dissolved in water, soluble in water. And when plants take up water, they take up these elements along with the water. It comes in through the roots and the root hairs, and they're held in the soil, in the water, especially associated with clay particles that are containing most of the charges in the soil. So you might read a different number than this, but there are 17 essential elements for all plants. And so there are a couple others that might show up on some lists because some plants need certain elements. So there are other books that might say 18 essential elements, for example. We'll go through those in a minute, but I'm a more generalist and a stricter science interpretation of this would say there are 17 that all plants need. And not only do they need all 17 of these things, plus maybe one or two more, but they need them in the correct amount, and they need them at the correct time in their life cycle. If you have too much of anything or too little of anything, it can be fatal. The plant might not be able to survive to complete its life cycle. And when I say complete its life cycle, that is generally meaning from seed to seed, healthy, viable seed. So for a plant to start growing from a seed to being able to produce a next generation of healthy, viable seed, it needs all of these elements. That's why they are considered essential to complete the life cycle. Now, the 17 for plants are very similar to what we need for animals. There are a couple of things that animals need that plants don't, but the lists are very, very similar. So let's first talk about our atmosphere. That thin layer, I mean, it feels thick from us, but if you view the Earth from the outer space, it's a relatively thin layer of gases surrounding the entire planet, made up mostly of nitrogen gas, N2 gas. It is roughly 78% nitrogen gas, which is an inert gas. Inert means non-reactive. And it takes a lot to get nitrogen to react. It can react. So it's not a true inert noble gas, but it is highly inert, meaning it takes a whole lot to get nitrogen to react. And so we don't use the nitrogen in the atmosphere. Very, very few things can. Bacteria are the only organisms that have the ability to chemically alter nitrogen. The next most abundant gas in our atmosphere is oxygen. oxygen taking up about 21% of the total atmosphere, and that's varied over the life of planet Earth, where oxygen was virtually non-existent in the earliest days, and due to photosynthesis from cyanobacteria, photosynthetic bacteria, and plankton, the atmosphere was dramatically changed to allow other life forms, adding oxygen to the Earth over a couple billion years. And that leaves just about 1% for everything else: the carbon dioxide, the argon, the neon, the pollution, the other things that make up our atmosphere, the gases that form our atmosphere. So the carbon is obtained by plants from the atmosphere in that carbon dioxide, even though as a percentage of the total atmosphere, carbon dioxide is measured in parts per million, not in a percentage. It's a very small percentage or proportion of the atmosphere. It is everywhere, and it's very important. And as you know from the discussions of global warming and all the issues going on with that over the last decade or so in our environmental consciousness here, even though it's a small fraction of the atmosphere, it has a huge impact on the way our atmosphere reacts to incoming heat from the sun. And so that carbon dioxide is used by plants to provide carbon. It comes from the atmosphere. So you need to know these three essential elements that are not considered nutrients. They're not considered nutrients, but they are essential. So carbon is CO2. You should know carbon dioxide, CO2. You should know how to write it, and you should know the name. It's also part of the photosynthesis equation, so you should know that one. Everybody should also know water. Water is the main source of hydrogens. And oxygen can come from oxygen gas as well as water. It can also come from carbon dioxide as well, but oxygens can come from all of these. And so when I'm talking about my nutrition, I don't say, hold on a minute while I get my US recommended daily intake of oxygen. Hold on a second. Okay, I got my oxygen. Wait a minute, I need a little more. No, it's not a nutrient. It's essential. I need it. I've got to keep breathing, but I don't consider it a nutrient. A nutrient we think of as the things we ingest as food. And so the things that are taken in as bulk, like water and oxygen for humans, carbon dioxide for plants, we consider those essential elements, but not essential nutrient elements. Keep those two separate. Now, the way this is organized is in nice groups of three. So you're going to notice here that I've got the first three, CHO, C-H-O, and that might help you remember. CHO, CHO, carbon, hydrogen, oxygen, the three essential elements that are the building blocks of life that are not nutrients. Then we're going to get into the nutrients, the macronutrients, which are in two groups of three. And then we've got the micronutrients, which is a group of 8. But at least the first 9 of the 17 are 3, 3, and 3, okay? Hopefully that makes it a little simpler. And here's the second and third group. The first 3 on this list, NPK, are considered the primary macronutrients, which are the ingredients for a complete fertilizer. So if you buy a fertilizer and it says complete fertilizer, it must contain N, P, and K in at least a certain minimum concentration or quantities in order to call it complete. Because when we feed plants, these are the 3 things we generally are most focused on because plants need a lot of them. They are macronutrients because plants need a lot. Now, in the in the English language, the term macro often means big and micro means small. But in terms of nutrients, macro just means I need a lot. Micro means I just need a little bit. The nutrient itself isn't big or small. To be macro, it just means I need a lot of it. Plants are constantly needing a lot of nitrogen, phosphorus, and potassium. And you should also know these compounds. These are things that you might be groaning right now, Triana, why are you doing this to me? But you need to know NO subscript 3 with a single minus, meaning it is an ion, and an ion, negatively charged ion. Ions have charges, anions are negative, and cations are positive. So NH4 ammonium is a cation, positively charged. So you should know NO3 is nitrate. That is the ingredient or the ion, anion, that plants use most to get nitrogen. Ammonium is used to a lesser extent for plants to get their nitrogen. Ammonium NH4+. Nitrogen is very complex. It changes forms. There's many different forms it can be in the soil. It can leach out into the groundwater. It can run off in surface water. It can volatilize and go up into the atmosphere. Nitrogen is very complex chemistry once it is turned into a soluble form like this. When it's in the atmosphere as N2 gas, it's very stable. It doesn't do much, doesn't react with much. But once it's reacted and turned into a soluble form, nitrogen becomes very reactive and very chemically active. Plants need a lot of nitrogen, and it's generally the most used of all of the nutrients. The next one is called phosphorus, P, and there are a couple of forms here, H2PO4 minus, HPO4 minus 2. Now, I'm not going to ask you to memorize the two chemical formulas. Just know that they're called phosphates. These are two different forms of phosphate, and plants take up phosphate. So they don't take up phosphorus directly. They take up phosphorus as part of phosphate ions dissolved in the water, phosphate. Phosphorus is the element, the atom. Phosphate is a form of an ion that contains phosphorus atoms, all right? Number 3 is potassium. Now the letter P is already used, so we have K for this. K represents potassium, and you have to go back in the history of the language of the elements to understand why, but it doesn't matter. Just remember, K is for potassium, and this one's really easy to remember, K+. Potassium is, it's not listed here, but in a solid form that you would find in a fertilizer, it's called potash. One word, P-O-T-A-S-H, potash. And potassium in its solid dry form, potash, when dissolved in water, the potassium is just a potassium ion, cation specifically. And it's the only one of the nutrients that's not incorporated into a structural component of the plants. It's not made into something. It's not part of the structure. Potassium stays as an ion in the cytoplasm of the cells. And it helps regulate electrical balances and osmotic balances. It regulates the salt balance of the cell and does many, many, many important activities, but it is not a structural component to build other things. Okay, so NPK, the 3 macronutrients. We have CHO, NPK, and there's no magic mnemonic memory aid for that, but NPK you should just know in agriculture, because people talk about NPK all the time. NPK this, NPK that. NPK is the fertilizer 1, 2, 3. NPK in that order. You may see a 4 ingredient fertilizer. If there is 4 ingredients on a fertilizer, that 4th one is probably sulfur. But these last 3 are also macronutrients, but we call them secondary macronutrients because when we are doing our crop production, especially in a non-professional environment, we tend to worry about these less. The secondary macronutrients are needed in large quantities, but they are often easily and readily available in the soil. They're already there. So calcium is all over the Earth's crust, and we might add calcium for many different purposes as a professional grower, but often we don't worry about adding calcium because of a nutritional need. Magnesium and sulfur, calcium, magnesium, and sulfur, the 3 secondary macronutrients. And there's no way to, make this any easier other than to say, memorize them. At least they're in groups of 3. CHO, CHO, the the essential elements that are non-nutrients, CHO, then NPK and calcium, magnesium, and sulfur, the primary and secondary macronutrients. And then we get to the 8 micronutrients. And you don't have to memorize the chemical form of the micronutrients. I'm not worried about that, but you definitely have to know the symbols and the names and the proper spelling of the names. A couple of them trip people up more than others. Manganese, maybe a little bit, and molybdenum all the time. But you are allowed a periodic table. There's no reason to spell things wrong when you have a periodic table. They're called micro because plants need small amounts. They're also sometimes called trace elements because trace means the same thing, small amount, trace amounts. They just need a little. So if you ever hear references to trace elements for nutrition, they're talking about the micronutrient elements. So I'm going to take a quick break.